Okay, sir. Okay.
Good morning, everyone. Let's begin our second session on augmented reality and visual reality use case in business model by Mr. Mahindra Balan GS, Senior Software Engineer, Sifi Technologies Limited, Chennai.
Hello, good morning everyone.
Hello.
My voice is audible, right?
Sir, just a minute. We will give an intro. After that, we will start.
Okay, sure.
Let's begin our second session by Mr. Mahindra Balan, Senior Software Engineer, Sifi Technologies Limited, Chennai. I feel immense pleasures to introduce him. He is a software or game developer with over 5 plus years of experience, primarily focused on implementing projects in simulations, extended reality, product visualizations, gaming, and other various domains. He has completed his UG degree in Karpagam College of Engineering in 2013 and then completed computer games and programming skills at IC80 Design and Media College in the year 2014. He started working as a game developer in Agri Software from 2014 to 2018. He then worked as a senior consultant at iLenses Technologies Private Limited from 2018 to 2019. He is currently working in many real-time projects in augmented reality field. We've been honored by your presence, sir. On behalf of VCET and Department of Computer Science and Engineering, we once again welcome you, sir.
Thank you. Good morning everyone.
Yeah, good
So
morning.
today we'll look into the extended reality. And its business use cases. So many of you have had a foundation of AI in the morning session, I believe. Uh, so let me tell you about how the AR and VR this the domain how it comes to be. Sound is not audible.
Yes, sir. Little bit, your voice is low. Yes, okay, sir. We can proceed.
Is it clear now?
Yes, sir. Yes, sir.
I'll just give a brief introduction how this innovation happens, these extended technologies. So first thing is like a crowdsourcing, how crowdsourcing is done. So what happens is like, so whenever innovation comes up, so some of the creative people just comes up with a good idea in the bottom of the ladder. So an organization has like two parts. One is the management part, top management part, and another is the level for working people. So the bottom of innovation is that the working people comes up with an innovative solution, which will be presented to the manager. And to the manager, if he finds that the technology is suitable for developing the future or something, he takes this up to the upper management and he funds for the investment. And what happens like whenever a company funds for a new thing, it will always shortage of funds. So what happens is like they will go for crowdsourcing. So crowdsourcing is like you apply for an idea or something, and what happens is like many of the investors comes to your technology and they look at it what you are going to future potential of the technology and they will implement it. That is called as outsourcing. Next thing is like once if you have the enough fund to start the technology development, next you want to go through like research and development, so R&D of the project. So what happened here is like the top management allows for the people to push actually. So the top management of every organization should be have with open ideas, not with an narrow mind. So they should be always has the mind to allow other people's innovations and everything. So that is top innovation. So this innovation comes from the management people. So the management people drives the working class people to innovate these all features. Next thing is like offering engineering. So offering engineering, there is no thing is called as one man invention or something. So it's always collaborative invention. So whenever you take off technology or whatever innovation it might be, so it is a collaboration of number of people. So this collaboration should be happening. So this all should be handled by the top management people that all the collaborations are done equally. Even for our COVID vaccine, what we have done is like there are a number of companies they share their reports and research find data with the other companies, and that is how they come up with the vaccination. So it's similar to whatever we done. It's also applied to the manufacturing industries, healthcare industries, and all the industries. So all the innovation has to be done in a collaborative environment. The next is co-innovation, which is co-creation. So once you're collaborative in the project, what you get out of the end result of project is a collaborative co-creating, co-creation project actually. So the technology, so AR, VR, and MR. So basically, what happens? It is not contributed by a single people. It's like it has a history of 40 years of history. So through the 40 years of history, it has developed with a single iteration, every single iteration, co-creation. So here we it is used by every class of people right now. So let's just explain a brief about new age technologies currently. So first thing, these are the big technologies right now. So cloud computing. So cloud computing is how we use Google Meet or everything. So everything happens over a cloud. So all your data are present in a data server, not in physical. So what happens like in past we used to have our data in hard disks and our own storage devices, but it is no more that. So everything is now is connected and it can be accessed anywhere across the globe. So that is called as cloud computing. Next thing is like big data analytics. So big data analytics is nothing. Uh, what happens like we have huge number of things. For example, uh, take an example of Facebook. We feed a lot of information. We feed a lot of information. So this information has to be processed and represented in the right manner. For example, we shop in Amazon, Flipkart, this kind of e-commerce websites. What happens is like you use to search for a single product and they find, for example, you want to buy a smartphone and these people recognize that you are interested in a smartphone. You used to continue search for 4 or 5 models. What happens like the AI behind the big data analytics, what happens to us? It analyzes for the data. So what kind of data, so what kind of searches you have done. So based on that, it gives you recommendation. So whenever you might have seen some ads appearing up in Facebook or some other site you go for, what happens like it's already based on big data analytics. So um, robotics is a next generation field also. So what we do is like we develop robots for our domestic purposes and for defenses also. So drones. So many of you have seen drones actually. So drones, what we thought of right now is like a instrument which we can use for photography or some other. But drones coming into a lot of picture lately. So what happens like in future, the e-commerce is like Amazon or Flipkart will be delivering our packages within the drone, and most of our traffic monitoring things and security surveillances all will be based on drone. Autonomous vehicles. So autonomous vehicles like self-driving car. So Tesla and a lot of companies are investing in this market. So what happens? So once the car should not be driving, will not be driving by a driver. It will be driving by AI. This is another set of new age technologies. So so this is automation. So automation is like we have very manual process actually. So for example, in the manufacturing industry, let's say that they are manufacturing a car by handcrafted something. So it takes a lot of time. So what happens if they mechanized all the mechanisms and robots used to work for it? So that is what is called as automation. This is IoT. So IoT is nothing, Internet of Things. So what we call Internet of Things is like all of our devices, smartphones, uh, maybe fridge, TV, everything is connected via Bluetooth or some other connectivity. So everything is connected to internet. So all of our OTT apps, for example, Amazon Prime, all these things comes into internet. And TVs, smartphones, vacuum cleaners, fridge, a lot of things are coming with internet-enabled devices, so that you can control these devices from anywhere. So artificial, I already spoke about, and artificial intelligence comes along with the big analytics, big data analytics. So what it analyzes your patterns. So analyze your pattern, it recommends things for you. Cyber security. So world is full of hackers and viruses. So people has to be guard against whatever the digital data materials. So for guarding these things, people go for cyber security. And at last we come for extended reality. So extended reality we'll speak about in next slide. So what we do. What is XR? So let me say like extended reality. So what is the reality is what we see, perceive and sense through our eyes, sound, touch and feel. That is reality. So whatever we sense and perceive is reality. Extended reality is something it's not real. It will be like extension of our reality. So what can our reality can be extended to? There are some things we can't sense. For example, uh, if you go to a retail market or some mall or something, you go to a market, okay. So what happens like you see number of products over there. Whatever you see is like only the items available. What if our technologies can innovate us and see the what are discounts available for the products displayed in the shelf or something. So that is extension of a reality. So beyond which we can perceive and recognize. That is extended reality. So extended reality it's an emerging technology also. So where what happens is like we implement computer generated environments. So computer generated environment means is like an environment which is created by a people or which will be superimposed on the physical world. So extended reality classifies into three categories. First is AR, VR, and MR. AR is augmented reality. VR is virtual reality, MR is mixed reality. So there is a continuum is there. So one end it is called a, so this extended reality has a scale. So what is it? One it is called as augmented reality. Augmented reality is something you fixed on a physical world. So you impose something on a physical world. I'll tell you the examples later in the part. And another end is like virtual reality. Virtual reality is it's completely immerse yourself into virtual world. Virtual world sense entirely your senses, everything covered in a detached from physical world, and you will be inside a virtual world. And in between these two is called as mixed reality, which has the best of AR and it has best of VR. So we spoke about extended reality. So what we do here? So we use chat for communication. For example, we used a pager in the initial days for the chatting communication, and we used Morse code in the earlier days. And now we use WhatsApp, Snapchat, and a lot of technology for chatting. But but all chatting is a one-dimensional way, and we consider all these are one-dimensional interactions. Unless you combine all of these, it's not a multi-dimensional interaction. So one-dimensional chat. So people chat to text, but if you chat, you cannot sense what kind of people emotions are. For example, if a people angry at you, if they reply, you cannot recognize it's what kind of emotion they have. You can just read their chat. It's a one-dimensional interaction. The next is a talk. Through the talk, what happens is like you can perceive the, the tone of the based on the tone of the people you can recognize what kind of emotion they are having. Are they really sincere or something? But it's still not enough to recognize. There's no visual feedback for them, so you cannot able to identify what kind of emotions of people are going through. Next coming type of communication is visualize. So the visualize what happens is like just think of the Google Meet call with no audio and there's no chat also. Just what people can just visually watch it. It is also impairment actually. So without chat and talk or talk without these things you cannot combine into a visual sentiment. So next thing is feel. So feel is what gives you a realistic feel. So whenever you physically grab an object, for example, you grab a cup of glass or something. So if you have a glass cup, what happens is you usually wrap around the glass with your fingers and you can feel with all the fingers how you are touching it and how you are holding, how much grip you need to have it. So that is how feel is done. So whenever you bump in an object, for example, wall. So if you touch a wall, you are able to say that you cannot go beyond that because it gives you a sense that it is stoppable there. So what happens if you combine all these things, chat, talk, see, and feel? If you all combine all of these things, this is the reality. So what happens in the extended reality? What we try to achieve is we provide close to realistic experiences by combining all these. When you able to combine all these, you will you feel the virtual world to be much more realistic. If you remove any one of these, what happens like the virtual world will become a uh, it will become kind of a game or something where you feel detached. You don't feel that much of reality. So based on these four types of interactions, we feel that the virtual world becomes much more real. I just hope you get what extended reality right now is. So I'll just head for the business part, how these things work. Extended reality. I'll give you a brief about this. Um, so for the this is the manufacturing sector. So manufacturing, just assume this image over here. Okay. What happens is like there's a kind of a machine over here. It might be a lathe machine or something. There is a automation process. What happens is like whenever a user needs to experience something. For example, a manufacturing a trainee or a technician will be there. For example, he needs to service a machine over there. So what happens is like he has to go to the machine and then to get another training. What if the machine is a very large scale machine which is not portable? For example, there are conveyor belts kind of thing. So conveyor belts also need a regular kind of maintenance or something. But what happens is like every technician has to be gone over there and has to see the conveyor belt and he has to learn from real-time environment. Unless the real-time environment, he is not able to learn from theoretical tools. Theoretical is like there will be a lot of instruction manuals and how to service and maintain those things. But in the end, it is not that much of helpful without the real-time environment. So what we do is like we have what about virtual reality? So what happens? Like, we mounted devices on it. What happens? We superimpose a virtual environment where we provide these large objects. Which so large object where he can identify each and every part of the conveyor and we can services and we can what happens? So it's a simulation. What we do is we can virtually simulate all the issues. So whatever the issues real conveyor faces, we can provide all these issues with it, and the technician can be given training on that by identifying those issues and how to fix them. So what we do is that we can literally uh, award the training based on his training experience. So we can give him some kind of sense of entitlement that he has done these courses, and for it's also taken for assessment part. So for companies like they can assess their training part to the virtual, so we can have assessment part for like virtual perspective and a real time. So think of that, once he is fully trained in a virtual machine, he is much more capable for implementing in the real time environment compared to directly dealing with the real time environment. So in the business part, I'll just explain. So drive top line by reimagining the sales of the B2B. So what like the entire sales can be differentiated actually. So whenever you provide B2B, business to business, the entire sales perspective can be changed. So people has to adapt with the upcoming technologies. So I told you before, like simulate virtual and that are impossible to replicate. So something like a conveyor belt of manufacturing is a car industry or something, for example, cannot be implemented. I mean, not every technician gets offered to go over them with it. So it can be created inside a virtual environment. So save cost and effort associated with the product demo. So just assuming the conveyor or something, everything has needs to be stopped actually in order to do that. So what happens if a production is stopped for training purposes from a certain day, for example, for every hour of a day, for example, 1 hour, they need to stop the production. And what happens is this training technician has to undergo all these things, I mean, learning things. What happens like they no need to we can entirely stop these product demos and we can reduce the number of time which we need to spend on the product demos. So it definitely serves the cost. So just think if you're saving up 1 hour of hour, the production line will be happening. So there is no need for stopping the training people. Another thing is like increase sales by enabling customers to visualize products. So uh, in industry we have a lot of companies for coming so for the real estate, healthcare industries, and manufacturing industries. They can implement their product in a virtual environment and they can much more visualize it compared to a pamphlet or a usual way of enabling customers is through a pamphlet or a product demo or something. But this enhances much more and this can be done remotely. Enhance effectiveness of learning. So by as I said before, like, it enhances the entire training module before it's appearing inside the real environment. So its entire training thing happens inside a virtual environment. So by the way, whenever he goes to a real environment, he may identify all the parts. So which increases his effectiveness of learning and it increases productivity. So the training stops, it will be increasing the productivity actually. So what happens like it will not be like slacking or something. So whenever he goes to a real environment, he knows what to do before it because of virtual training. Enhance productivity and reduce risk by enabling every technician to have access to information. Another major drawback is whether like so they will be provided with an instruction manual or some kind of pamphlet or something. What happens is like whenever an issue comes up, he has to go through all the information. So he will not be facing every time the same kind of issue. So the technician will not be have the ability to handle all the issues. So what happened here is like we provide his hands-on training in the virtual world, so that he can have much more. We can also simulate all the issues, whatever happened in the real world inside a virtual environment, so that he might have faced all the issues, so that he can have much more confidence in this maintenance and repairing ability. So digitized technician engineers to solve things faster, safer, easier. It's the same point. So what happened? Digitized. So every technician will be digitized now. So they can have an own training sessions inside a virtual environment, so that everything becomes faster. So he may able to identify the issues much faster and safer and with minimal. So there are some kind of maintenance which may be riskier for maybe a, if it's in a healthcare industry, it may be health risk. If it's a manufacturing, it may be in some kind of wounds or cuts, those kind of risks. So these risks can be minimized. So extended priority offers pioneering new ways of maintenance, repair, and workflows. So by training in the virtual environment, what happens is like the entire strategy of how we train the technical staffs will be changed in the future. This is extended reality for education. So what happens is like I was shown an image of human anatomy model. So what happens is like we have an iPad over in the screen. So what happens when you scan this, it's able to say what kind of information are these. So is it a lung, or is it a heart, or a liver, or the throat, and those kind of information can be displayed. So education is a primary part, one of the major part contribution actually. So what we do here is like enhance the digital learning experience. So during the COVID session, like COVID reason, we are all going for the online action. So all the classes are conducted in the online. So this will be much more happening. So even COVID is not happened, like we'll be moving transitioning to this digital age manually. So for example, I'll just give you an example. So assuming you have a bookstore, what happens is like if you scan your books, you can have a virtual environment projected on that. For example, learning about a heart or something, you can scan the heart. What happens is like immediately 3D heart. So what we learn see through is in the book or a board or 2D. So 2D is like it has only two dimensions. So you don't have anything else more. In three-dimensional perspective, you get much more. You get depth actually. So you can rotate the heart and see what kind of abnormalities or what kind of how much a valves and heart have, and those cross-sectional view. All these views can be done in a 3D perspective. If there is a 3D, because human we perceive through 3D because we see depth also, not just 2D planes. We see depth also. So if a if a student able to identify in a 3D, his learning experience will be much more. Next is like increase effectiveness by learning. So the learning experience will definitely be increased for students, and students will be now engaged with the new ways of engagement section. So students will be engaged with the different engagements. So, a number of methods will be. So all the colleges and staffs will be need to implement a new way of engagement for the students. How to teach them. So the interactive development will be different. So next is drive pressure to accelerate early enrollment by extra power campaigns and virtual campus tours. So what happened here is like we we accelerate this growth by using campaigns and virtual campus tours. For example, for example, a science competition or something, he has to present something virtually. What happens is like he can entirely present his solutions or innovations through virtual tools, and where he can learn suitable things for simulate virtual environment that are impossible to create. It's the same thing. There are a lot of things will be unable to create. For example, uh, if you want to learn about anatomy of a human or something, what if you want to learn about anatomy of some other animal or as a cross sectional of some other creature or something? What happens is you can implement those kind of things in over here. So this is a very deep. So I already spoke about a small part of it. So what happens is like you go to a supermarket and you scan a shelf over there, and immediately what it shows it shows how many discounts or what kind of product it is, or it can actually show what kind of location you are. Are you in the location where you can get groceries or you can get some other products? So what happens in the business perspective? It is the returns and logistic expenses. So what? Just think of a virtual reality superstore, supermarket or something. You go to Amazon and purchase for the products, and but you are unable to view the product fully because it's just an image. You cannot see what kind of product it is. Just imagine an entire supermarket within a virtual world where I can pick up some item and you will open or see what kind of item it holds inside. For example, there's also a remote or something. Let's just say where you can pick up the remote and you can see what kind of remote it is and all these things. And you can also interact with every product. What happens like this also product people will be much more clear about what kind of product they are getting visually. So it's reduce the risk of product returns and logistic expenses. So most of us, whenever dissatisfied with the product, we have returned or damaged we have returned to Amazon. What happens is like if you want many people, for example, if any of you have bought clothes over online, the size might not be fit or something. What if you can visually enhance the size of the cloth through wearing inside a virtual environment and see that if it is fitting you or not, so that you can order your correct size person. Next is like accelerate B2B sales and reduce. So it also accelerates B2B sales. So every business can be extended with extended reality. Extended reality. So it increases their profit over time. And last point is like drive top and by transforming in-store experience to home experience for work from home markets. So within work, I mean, by staying at home, you can always have this in-store experiences. So whatever you visualize, you can visualize it. So if you currently go to a car manufacturing website, so for like recently MG Hector and things kind of thing, what they do is like they have this browser-enabled AR experience. So whatever you can click on it, you can transform by placing it you click on the car and which model you need to select it and place it on a floor. So the car appears to be appearing inside your home. So you can have a 3D full 360 walkthrough of the car experience. So it reduces the possibility of needing to visit a store, showroom. Next is extended reality for healthcare. So healthcare is similar. So the medical training and education is given for the medical professionals, and patient education adherence to plan. So patient education can be most of a patient who goes over there have a complaint about that there's not a good explanation from the doctor or something. For those patients, what we can do is we can educate the patient to know what kind of disease or disorder they have, and they can plan much more ahead. And you might have seen some videos where we can superimpose certain things over there. So Microsoft HoloLens is one of the device. What happens? It superimposes some computer generated data on the surgical instrument. So that what happens? Like, medical professionals will be much more precise in the operating their surgeries. Next is like we have heard about MRI and CT scans. So always the MRI and CT scan actually what it receives the data as in a three-dimensional view. But what we do is like the three-dimensional data is like taken snapshots into a different many images so that doctors can view into like there are like front view, back view, side view. All these views are there. So the doctor should be able to view each view individually. Uh, what if the MRI and CT scan can be done in a three-dimensional way? So all the 3D reports can be printed. So imagine the image of your. You need to see the spine. So
Sir, please, sir, sir, sorry for the interruption.
also,
Sir, your voice is not clear.
okay.
If it's little bit louder means it will be better.
Is it good now?
Yes, sir. Fine.
Okay. So identifying the treatments. So for example, there is some kind of abnormalities in the spine bone or something. All this identification can be in three-dimensional. So it will be much more easier for the medical professionals. And one more thing is like these all these reports can be shared between the stakeholders. So for imagine if all these virtual environments can collectively combine. So whatever a medical professional views, and another person also view the same kind of a thing, or he can do different things. So they can have a shared report of what they're doing. Okay, since you have a brief and introduction of today morning, so I'll have like a short brief about what virtual reality is. So virtual reality is nothing but just imagine you can see over the image over here. It's a virtual world. It's completely different from what reality is. What happens when you wear the device? It has two displays inside the device. So what happens? You get the stereoscopy. So using 3D stereoscopy is similar to watching a 3D movie or something. But what here is like you completely immerse yourself in this virtual environment. So VR includes a cognitive and perspective presence. So cognitive is like visual presence. Perspective is like your sound, touch, and all those perceptions will be there. So there are several sensors which handles these things. And a virtual reality provides natural physical interaction. There are some haptic glosses. So what are you like? You can whatever you feel in the real world can be simulated in a virtual world. So what makes things as virtual reality? So these are the some things which are combined to make virtual reality. So one is like real-time 3D rendering. So all the time what happens is that the entire 3D is rendered around you. So entire environment which is designed in 3D will be rendering on you. Stereoscoping nothing but two displays will be there which will be placed in an angle where we perceive human eyes tends to perceive it as a 3D, so that we have depth perception. Next is spatial tracking. Spatial tracking is like the awareness of environment around you. For example, just assume the device scans entire environment, and it knows where not to hit the wall and everything, so that you can move within the virtual world. Haptic is nothing but so when you use your smartphone, if you type it on it, you can get a small vibration kind of a thing. That is called haptics motor. So what happens is like this is what makes you feel that you are typing. So initially, what we use button phones actually. So in the button phones, what I'm like whenever you press a button, you get a haptic. Like it's pressed and your the button is coming back. That is a kind of feel you get. So in order to what we have moved to smartphones with touchscreen. So touchscreen doesn't have a button or something. In order to simulate that same kind of feel, what we do is we have a haptics motor in our every smartphone. So if you click on it, it gives a small vibration so that you feel that that vibration comes from the button you press on or something. So that's how you make you feel that you are actually typing it. Without that, what you feel, you're just like tapping on a flat surface. You don't have the feel. That is haptic. So what we are here have here, like, we have number of sensor across the user actually. So we have hands, we have shoulders, and what happens is like all these feedbacks will be provided that so that the touch and feel of the user becomes much more real in virtual environment. Next is 3D sound. So 3D sound is nothing but so sound is a main part. So we go to movie for only for sound purposes. So and for theaters for the sound purposes, because the entire audio is very important, because based on the audio you know where it comes from. So the audio makes it much more realistic. Next is 3D interaction, and 3D interaction and spatial tracking go hands in hand. Uh, just imagine you're going grabbing an object inside a virtual. For example, assume there is a gun over there, so you need to grab that gun in a game environment. So that kind of interactions are, so you grab the gun and you shoot by pulling the trigger. So all these things happen in a 3D interaction. And all VR devices are HMDs. HMD is nothing but head mounted displays. So you can see the user over here mounts something on his head. So all devices comes with this kind of setup, so that his immersive his eyes are fully covered, so that he's completely immersed, detached from the physical environment and immersed in a virtual environment. These are the use cases. So I worked in a number of variety of fields, so from gaming to healthcare, manufacturing industries, and I've done several different products. So these are some of the main areas where the virtual reality applicables. So healthcare and medical sectors, medical and healthcare sectors. So the doctors are trained within these things. So what happens like they go within a completely and entirely virtual world. So you can by the see the image over here. So the entire world is like completely virtual. So they can go over and interact with that. Next is manufacturing industry. So just assume here they are assembling a motor or something over here. So they can check on their camshaft part or something, everything, and they can provide training. So and virtual reality majorly benefits from gaming actually. So there are a lot of games coming up, and gaming is one of the industry where whatever the new technology comes up, it revolutionizes. So even before it is used in healthcare and other industries, gaming was there present more than 10, 15 years. Virtuality can be used in education for learning purposes and can be marketing. For example, just assume you're marketing a house or something, or you need to market something, a new house. What happens is like they can show around a virtual tour of your products. So through navigating through all the rooms, and you can just virtually experience within your home. Another is 360 cinema experience. So what I'm like, we used to watch cinema or movie in a single picture actually. We just fix it a certain portion, we don't rotate around that much. But what if entire video wraps around us, and you can visually you can turn around 360 to see what all the environments happening in the movie, so that you get a full experience. There's 3D virtual communication, future of communication. Like currently, we use Skype, Google Meet for video and purposes. What if 3D virtual reality? Like, another people appears for you, so that you can have much more good conversation. So entire avatars can be created. People's avatars can be created, and they can be applied in the virtual world. And last is like training and education. So we have contributes a main part in training actually. So we can train a lot of technical staffs so that they can reduce their amount of learning efforts in the real time. So these are some of the devices, popular devices currently. So this one is Oculus Rift, this is Valve Index, this is HTC Vive Pro, and this is Oculus Quest. So Oculus Quest is the currently much more from Oculus Quest and Vive HTC Vive Cosmos. These are the currently very popular devices which many clients prefer now. Okay, so that is for the virtual reality. So augmented reality, it's different from virtual reality. What happens like here we don't have any virtual environment or something. What we do is like we extend our physical world, and we implement superimpose a 3D model on a physical world. So that is what is it. What if like for example you're shopping sofa or something. So what if we need to visit the shop, but many of us will have a brief don't have idea how much the sofa looks inside our house, or how much size it fits inside our house or something. What happens like using augmented reality, we can place the sofa or other products inside our house, and we can see if it fits nicely or something, and we can even see where we can place the sofa. We can turn, tilt, and we can do all sorts of operations on that, so that you can have a good idea how it works in it. So these objects which are physically rendered will be 1:1 scale size of the real world, so that people have a good perception of like how it looks. But for augmented reality, too, we need a display, because without a display, we cannot have a augmented reality. So it's projecting physical world, projecting on physical world. As I said, AR combines real and virtual objects in real environment. So it registers and aligns real and virtual objects with each other. So what happens like actual in this room there is no sofa or something. What happens like, but once you scan the floor, you place the sofa, it looks like there's a sofa inside a hall or something. So what happens like it there's the image processing will be happening behind it, registers and aligns to the however the real world. So it augmented reality can easily recognize is it a floor or a wall. So those kind of recognitions helps in aligning the virtual objects. So as I said, AR comes in smartphone, HMD. So AR also has some wearables and some browser-enabled cameras. And AR also operates 3 dimensions. So AR also, it's not in a 2-dimensional way. So AR also operates in 3-dimensional way. And AR augmented reality has 3 major types. First is marker-based. Second is markerless is tracking. Third one is like SLAM, which is location-based tracking, simultaneous localization. So marker-based tracking is something. What we do is like just assume take this as an example, okay? So what happens is like there is a sheet over here. There will be a marker, some kind of unique marker. For example, it can be a QR code also. This QR code generates a house. So this is your next new apartment which you're going to live in. So you need to see how it looks from exterior or something. What happens like you have a sheet of paper and your apartment QR code information printed in a QR code, and you can scan using a mobile application, and this model is downloaded and it appears. So this is marker-based tracking. Next thing is like markerless tracking. Markerless tracking is like something which I've shown over here. So there is no marker over here or something. So it is entirely a sofa is placed on. So markerless tracking is much more advanced compared to marker-based tracking, since it doesn't have anything to begin with. So based on the environment design patterns, it takes the marker tracking and it applies the virtual object over there. And third one is like simultaneous localization and mapping. This one is like location-based tracking. So what we do is like, for example, you're crossing a mall or something. What happens like immediately a message pops up for you that currently a 50% discount is available in your retail shop nearby. Something. And or if you're viewing through some kind of a glasses or something. Some of you have seen smart glasses, I guess. So what happens is when you wear a smart glass, it's similar to a virtual environment, but what happens it superimposes on a physical world. For example, I have just seen over here. So what happens it superimposes on a physical world. So people go over there and recognize. So based on your location data, it gives you a pop-up, a real-time pop-up or something, where these kind of discounts are available. Would you like to visit or something? This increases business use cases. So AR were majorly used for this one. So industrial design and training. So I just shown the below image. You can see over here. So there is also some connectors over there. So how to, these are not touchable or not touchable. So green markers are touchable and red markers are not touchable. So you can interact with these things. Next thing is like tourism and sightseeing. So just imagine scanning a mountain or something. You can see where is peak of the mountain or something. For example, if you consider Ooty or something, the peak is called as Chottabeda. Just by scanning the mountain, you can able to see where is what all the locations are available, or from a top view or something, what kind of hotels it resides by. So these can be used in tourism. Next thing I told you about is retail shopping. So you go to a supermarket and you can easily see detail of the products or discounts available there. Next thing is like defense. So augmented reality is majorly used in defenses. So head is like heads-up display. This is used in fighter craft, jets or some jets, and a lot more vehicles actually. So what happens like your information will be displayed on a glass actually. So instead of looking at a display or a physical display or something, the information will be directly displayed within your glass. So it looks like it's appearing on the air. Next is archaeological museum. For example, archaeological museum, like we have certain distances when we look into the museum or something. So what happened here is like you can scan the image over there and you have a good recognition of how it looks in real time. So it's used in medical field and research. So medical things, so same thing. Doctors can be trained visually. So how this implements, so they can scan a patient or something, they can have a good idea of where the where their details and what their operations are. So augmented reality also majorly benefits for education. So education they used for this. So as I said, like for textbooks and a lot of things. So education is like an upcoming field. So education is like slightly transitioning for this AR and VR. So still there are much more innovative ways for in the near future. So these are some of the devices for AR. So this is Google Smart Glass, which you can wear all the time. This is Vuzix. This one is Magic Leap. This is Microsoft HoloLens and Magic Leap and HoloLens. It's much more different from augmented reality. What is like it is much more mixed reality they call it as, because it hosts both virtual and augmented reality benefits. So it's called as mixed reality. So many of you heard about Pokemon Go, I guess so. So this is a popular game, a popular augmented reality game, where people can go to a certain location. So as I said, Slam. So which is they go to a certain location with their location data where they can scan the environment to find a Pokemon over there. So it's a very famous game across the world. This one is broadcast AR. So you can type it in Google or YouTube to see how it works actually. So broadcast AR is nothing but we have a DSLR camera or something which projected on top of a ceiling or something. And what happens is there will be large display over there. So what these things can be done for large mall interaction. So wherever the large area is available. So for example, mall interaction. So malls have huge spaces. So they can have this. You can interact with the tiger, or you can interact with the elephant or dolphin, and those kind of lot of things are done. So National Geographic, Discovery, they have done a lot of broadcast AI stuff. You can go to YouTube and visit and see what those are. So so I told about the AR and VR. So I'll tell you about what kind of platform it supports currently. So the platforms are Windows, Microsoft UWP, iOS. iOS is nothing but Apple's iPhone OS, Android, Mac OS, and web browser with ARML. ARML is nothing but augmented reality markup language. So some of our new smartphones, new generation smartphones recently for a year or something, OnePlus and some higher end smartphone supports augmented reality within the browser itself. So there is no need for an external. What is the need of browser is like you can just open with a link or something. For example, Skype is a tool which we need to be downloaded locally in our PC. Then we need to connect it or something. Assuming Google is like runs through just web itself, there's no need for a manual client to download. So this is what reduces. So every previous generation was like every AR was like we need a application to develop and which need to be inside whatever platform it is, Android or Windows or something. Now web browsers are integrated with ARML so that you can use with just a link you can view your AR contents. So these are some of the tools, popular tools which are used to develop AR and VR. So Unity 3D, Unreal. So these are game engines. So popular game engines are now used for developing these tools, AR and VR, because these game engines, what happens like they support a very good 3D environment. So they popularly used for that Unity 3D and Unreal. 3JS is something I just told about web browsers and with AR. So for web browser they use 3JS, and for native development there are supported as Studio, Android Studio and Apple Xcode. So these can be directly implemented without using third-party tools like this. So it is proprietary for their each for Android is for Google and Apple Xcode is for Apple. And these are so we spoke about softwares. Now we spoke about AR tools. So what are libraries? Widely used libraries available for developing AR content, augmented reality content. So Euphoria is a major player. It's been more than 10 plus years of in this field, and there are these are other things are relatively new product which has less than 3 years or 4 years of existence. But Euphoria is much more 10 plus years of experience. It supports most of the mobiles and a lot of platforms supports augmented reality. And Google's own innovative for AR is like AR Core, and Apple's has is AR Kit. So Unity has AR Foundation. Your AR Foundation nothing but it's a combination of AR Core and AR Kit, but it invents it has much more better tracking compared to individually using these things. So Magic Leap is a relatively new device which comes up, which is a mixed reality device. Next is WebAR. WebAR is about developing content for web. So VR toolkits. So VR toolkits like is as Oculus. So Oculus is a popular front. So for every individual devices, they have their own SDKs. But what happens like once the Excel starts to develop or something, they have too many SDKs. Now people go with OpenVR or SteamVR. OpenVR is like it's a universal SDK. So what happens like whatever SDK developed by any companies has to be compatible with OpenVR, so that all the contents of the VR can be transferred to different device without many issues. So portability has to be a good thing. So this is business use cases for B2B customer, B2B. So B2B, what happens like this is so transportation has less than 20%, and retail is coming up. So for the popular retail companies, IKEA. So I think some of you have heard. I think so. IKEA is using their augmented reality app to see whatever furniture you can be. Even you can see and download the app and see. And in foreign, some they are using it for aquariums and other things. They are using tourism. So industrial development is happening within India also. So a lot of trainings are happening in the for the industrial development side. So manufacturing is same. So from picking the raw material to meeting the end goal product. So from entire processes training has been done down. So it has a huge market share. So our main projects comes from manufacturing and medical industries. So medical is the one has been supporting the extended reality technologies for a lot of years, so 10 plus years or something. A lot of trainings and product demos are done in the medical field. So this one is like B2C, so business to customer. So majorly these are consumer usages. So what consumer use for example, transportation is not a viable option, but now lots of map reviews. You can see that Google Map comes with 3D kind of thing. So all these things comes with augmented reality. So your maps are accessed with this, but many people are not consuming it right as of right now. And tourism industry, people used to scan pamphlets to see whatever the location they are in. So e-commerce are coming up. So e-commerce, they have a virtual product tools. So as I said, like for a product to in Amazon or Flipkart or something, you can visualize the 3D product through augmented reality or something. So a major market share is like television and gaming. Television is like movies and your cinema experience. This is what people mainly purchase these VR headsets for. And gaming is the next thing. So as I said, Pokemon Go and lot of VR games, Beat Saber, and a lot of games. So gaming is what kept extra XR industries alive for so long, because people do a lot of games in that, and that is how XR industry is sustained over the years. And I'll just give you a small brief about it. So whenever a new technology grows, there are certain setbacks for the technologies. So these are the setbacks and how it goes through the setbacks and finally comes into a product. What happens is like technology trigger. So like idea has to be generated. So is it possible to implement or something? A drastic idea. Next is peak of inflated expectations. Whenever new technology comes, there will be a lot of expectations. So unrealistic expectation. For example, even if we are, unless you experience a lot, there'll be a lot of expectations with that. Will it be really this much realistic or something? But these all these expectations are inflated, not actual one. Next is trough of disillusionment. So disillusionment is nothing but you have illusion of a technology does this, a textile does this, but it has every technology has its limited scope. It's not, for example, virtual reality. It offers close to realism, but it's not entirely real. You can able to tell the difference. Still, we are not yet into that direction. So you need to have this disillusionment. So what is like? You need to have your preconceived ideas of technology, how it works or something. So you remove all these preconceived ideas, and you get to see what the technologies actually is. And then is slope of enlightenment. Slope. This is what. So when the image you can see over here is like when people tell about virtual reality something, they can imagine a lot more possibilities something. But actually, what it happens is like you don't have a real hand or something. You have some controllers and a headset or something. So this is how a real virtual environment works. So this is the entire setup. So this is where you get enlightened how a new technology is going to be, not with the inflated expectations. So I just want just quick graph about this. So this is about a 10 years graph how augmented reality was there and how it was implemented. You can see. So this is have a graph. So this is expectation you can see, and this is technology trigger, inflated expectations, disillusionment, slope of enlightenment. This is plateau of productivity. Plateau of productivity is like which it is currently used widely used technologies. So what happened like in 2000 level, the augmented reality was far back. So it was in the augmented reality was very much hype because a lot of investors were invested, and there was very bad investment also because of highly inflated expectations. And virtual reality was at the disillusionment because virtual reality was much more present before compared to augmented reality. So there was a slight expectation how much real can be done. This is 2012. So still 2012 also the augmented reality is still in the inflated expectations, and same things happen. Next is 2013. So augmented reality has set all the expected inflation, inflated expectations were removed. Now it is in the process of disillusionment. So it removes all the unnecessary expected ideas, and it goes into what can be possibly achieved. This is 2014. So it's still in the facing of having removing from all the preconceived ideas. 2015 also same. 2016. So virtual reality has moved a step ahead. So this is what Facebook's Oculus Rift and Oculus Quest was getting popular. So Oculus Rift was very popular, and a lot of games were played for it. And this is the point where 2016 is where consumers used to buy the virtual reality. For before that, virtual reality products were very on the costly, cost about a lakh before. But now it is up to 35,000. You can acquire a virtual reality devices. This is year 2017, and augmented reality is still far behind, and virtual reality is there. This is 2018. Now virtual reality is like many products has been because in 2018 we were giving a training for people actually. So we are used whatever products developed are used by the training people. So virtual reality is much more mainstream compared to because healthcare and manufacturing industry have adopted this, but augmented reality was far behind still. In 2019, this is where 2018 is where AR Kit and AR Core was launched, and 2019 it picked up a lot of things. So in 2019, what happened is like this AR, Android and Google and Apple and Google set a standard for the AR. What it can be capable of something. That is where a lot of users comes up with okay, this is what possible in AR, not all the inflated ideas. So they engage the AR in a right manner. So as of 2020, all the AR, VR, MR is a mainstream now. So everything, all the technologies which are in the height of inflation expectations were completely into a mainstream now. So this is one of a pioneer of artificial responsibility, which is Google Toothbrush, so which I've shown in the a video over here. So this is future of engagement. So we'll be entirely using this. So all of our realities will be extending by AR or either VR. So we'll be having depending on these devices. So this is our future of engagement. Thank you. Uh, so anyone have any questions? Please ask.
Participants, if you have any queries, you can post in the chat box or you can unmute yourself and ask. Sir, kindly check the chat box, sir. Someone has asked the question.
Just a minute. Uh, Google invented a hardware which is a much more cheaper device which you can get for 200 rupees or 300 rupees, which is like you can use your mobile phone itself, which can be connected within a hardware device, so that you can use it. So you can search it as Google Card. What happened like two lenses, it uses a mobile design which converts into and VR, but the experience is much more not realistic, but it gives you an experience of how VR looks like, and it's an expensive. So it costs you around 200 rupees or 300 rupees plus. Google does have this AR device actually, smart glasses, but they discontinued, and they are having in future of upcoming plans because the technology was too high at that time. Expectations were so unreal, so the product failed. Uh, Configuration details. Can you be a bit clear? What do you mean by configuration details? I mean development pipeline of AR. I mean, I guess. So AR and VR both have almost similar development pipeline. So whatever like earlier I mentioned about software tools. So use either Unity 3D or Unreal Engine for development purpose, where you have to install some development kit. So AR has lot of libraries. For example, Vuforia, Android AR Core, Apple AR Kit. So these are libraries for AR. So what happened like you need to import these libraries into the Unity application. This is a tool. Then you can develop some 3D content for that. So in upcoming session, you might know about 3D designs actually. 3D design is nothing but, so we have seen 2D diagrams as a picture. So think it of as a three-dimensional design object actually. So these objects are placed inside that environment and it is development system. And you can build to the whatever respective platform. Yes, so you used Snapchat, I guess. So all these filter like a dog filter or a smiley kind of face, and all these filter are using AR technology only. So they use any one of the mentioned AR kit tools I mentioned, Euphoria or Android or Apple's AR kit. Yes.
Participants, any other queries? Thank you, sir, for describing the various business model use cases, augmented reality and virtual reality toolkits, etc. And it was an effective session for the faculties. Once again, we thank you for your valuable input, sir. Thank you, sir.
Thank you.
Participants can join the next session at 1:30 p.m. with the same link. Thank you. Thank you all.